guys, it is me, Trollface the Man, and welcome back to another PCRT, or Potassium Chlorate reaction test. Today we are testing thermoplastic, which are these like sort of plastic pellets that when you heat them up with, put them in hot water, they melt and you're able to shape plastic, basically plastic items by hand. It becomes almost like a soft putty, and then it turns back into plastic when it hardens. It's actually a pretty unique material. Now let me tell you one thing. I made a solid fuel to test afterwards, but this stuff, these pellets, are like, this plastic in general is like the most indestructible thing I've ever had to deal with. I tried putting the plastic pellets in a blender. They just spun. They didn't actually blend up. I then tried making a big chunk of plastic and then taking a file to it. The plastic just ended up jamming up the teeth and it wouldn't shred at all. Tried drilling the plastic. The drill, even when moved extremely slow, would just remelt the plastic. So eventually what I end up having to do is take the thermoplastic, melt it, make a very thin sheet out of it, and then keep blending up the sheet in the blender. But the problem is that if you just blend it up continuously, the sheet would heat up and then start sticking together. So I had to blend it for about 30 seconds, put it in the freezer, blend it for 30 seconds, put it in the freezer, and repeat the process over and over again. And this is the best I was still able to do. So we have sort of like these flakes here. I could not get it any better for the life of me if I tried. So this was suggested by Sean Burke. Thank you very much for your suggestion, and if you guys have your own suggestions, please leave them in the comments below. This is 2 grams of the thermoplastic to 4 grams of potassium chlorate per the usual. So I'm going to mix the two together and just shake it up, and then we're going to light it up and see how it does. Of course, I don't expect it to blend up very well because we're dealing with flakes here, but I suppose it's good enough. Alright. Potassium chlorate reaction test. 2 grams thermoplastic to 4 grams potassium chlorate in 3, 2, 1. I can tell you one thing already, it smells pretty bad. So the plastic itself doesn't seem like that it works too good mixed with potassium chlorate. But like I said, I actually made up a solid fuel that we can test right after this and see if it works any better as an actual solid fuel with very fine particles of potassium chlorate mixed in with it. Which that too was a pain in and of itself. So yeah, that definitely was one of the least eventful PCRTs yet. Like I said, that plastic might not just have a lot of potential energy when it comes to being mixed with potassium chlorate. But like I said, I ended up making an actual solid ball of this stuff. What I did is I took a pot, filled it full of water, put a plate on top of it, let the water boil, heat up the plate, have the thermoplastic on top of it so it keeps melting, and as it melts I keep putting potassium chlorate in there, folding it in, mixing with the plastic. So this is 4 grams potassium chlorate mixed with 2 grams of this plastic as a solid fuel. And let's see if that does any better at all. So already the results aren't too promising. right, well, it did a little bit better as the solid fuel, but I wouldn't say that it did a whole lot better. If you plan on using thermoplastic to make a solid rocket fuel, I would say that it's probably not the best option. Thank you guys very much for watching. If you enjoyed this video, if you found it informative, please remember to give me a like, to subscribe if you haven't already, and to share this series with your friends. That really helps the channel grow and is very much appreciated. Thank you guys for watching, and bye!